Alright, so let's take a look at another example of what we can do with velocity fields. So this is something interesting. So we're primarily going to do like sort of like a river simulation happening over a terrain. Okay, so this is the final result that we'll get. And in order to do this, we're going to use one new node called as the proximity node. Okay, so what it does within the particle SOP is that it calculates the distance between each particle and gives you an attribute. So you can actually use that attribute for p-scale as well. So if you want particles to scale up based on their distance from each other, you can actually do that. Okay, but we're going to use it to sort of help calculate some of this stuff, especially for coloring. Alright, so let's get started. Right, so I'm going to take a new file and we're going to create a terrain. Okay, so let's take a height field and I'm going to make a very small height field. So it's always very tricky to control a small height field because most of the noise settings are pretty massive. Okay, so the first thing you need to do is you need to get the grid spacing down fairly low. So make it about 0.01. You can also make a normal size terrain and then scale it down. That's perfectly fine as well. But this is the way that I went about it. Alright, so once we've done this, what I want to do is I want to create a terrain that looks sort of like that. Okay, hold on. Yeah, there you go. Okay, so we just want we want flat on the side and we have these mountains in the middle. Okay, so I'm going to first start off with a pattern and the height should be 1 and the pattern will be let's keep it to star and we'll just lower it till we can see it. So we'll get the pattern down to, let's try 0.5. Oh no, hold on, bigger. Yeah, I think this is okay. Let's keep it to 10. And then change this to ramp and we're going to change it to concentric. So it will be circular like that and reverse it. Okay, and then just sort of, bring it in like this. And I'll just set these to like a B-spline. So it's smooth and a little bit like that. Okay, and then just give it some distortion. Get the element size down to 10 and the amplitude down to 1. Okay, so just a little bit like this. This should be smaller still. Okay, so this is good. Now let's take a noise. So we'll take a height field noise and turn off center noise. I'll get the element size to about 5 and the amplitude to about 10. So we'll get this and set the combine method to multiply. So we'll get that. Okay, now what I want is I want to adjust this so that it has more flat areas. So come to post processing and turn on gain and bias. And the gain will come to around 0.9 and the bias will be around 0.2 or 3. I think that should be good enough. And then just adjust the offset till you get something that you like. So we'll just move it around. Yeah, I think this looks nice. Okay, let's just lower the amplitude a little bit. Okay, so this is good. This is the landscape that we want. Now as a final thing, and this is important. Okay, so we need to generate, we can't use erosion on this, okay, because it's too small. And if you use erosion, it'll just destroy the whole thing. Besides, we don't want to erode it. Okay, the only thing we want is we want a flow field because we're going to use the flow field to move the particles. Okay, so just connect it to a flow field and you'll get this. Okay, and then just make some minor adjustments. So I'm going to adjust the height, make it about 0.2. So it sort of eats through it. And I'm going to lower the rain amount, make it 0.05. Yeah, I think this is good. And let's also do one thing. We'll make it smooth. Okay, I think this is fine. Let's get the height to 0.1. Okay, so this is fine. And then you can remove the copy to mask. So this is the landscape that we have. Now what we want is, you will find that it will have 3 fields it'll have a flow field, but it'll also have flow direction X, Y, and Z. And you can sort of visualize this if you want. Okay, so what I can do is, firstly, I'll convert this to geometry. So let's take a convert and we'll convert the height field over to polygons. And we'll get the density down to about 0.7. So it's not that heavy. And it will automatically transfer the, the flow to like flow direction underscore X underscore Y underscore Z. This is what we'll be able to use. So let's do one thing first of all. I'm going to generate some curvature for this. So we're going to use the curvature to set the density of our particles. Okay, so we'll set this to the element type to points, and I'm going to set it to curvature. So this is okay. And then I'm just going to take a color node and I'll set this to ramp from attribute, pick up curvature, and just lower it around 0.5. So this will set up our density. All right, now the next thing is I want the particle emission to start from top and then go downwards. Okay, like as if there's like rain falling. So what we'll do is I'm going to take a box and we're going to generate a mask based on that. So I'm going to like just scale it up. Yeah, I think this is okay. And then just adjust the height till it sort of covers the whole thing. And so move it up here. I'll take a mask from geometry and I'll do alt click and we'll come to 48 and I'll move it down to, let's say about there is fine. So we should get this. Let's do one thing. Let's just block off the base. Yeah, I think this is fine. Hold on. Let me just lower the radius a little bit. Okay. Okay, this is good. So we probably won't get any particles happening on the ground level at all. But we'll see if we want to adjust that, we can adjust that a little later. Let me just try to go slightly lower. Okay, so this is fine. All right, so now we need to do two things. Firstly, I want to get this color mixed with the mask. That will be my emission. And then I want to take the flow XYZ and put it into velocity. So what we'll do is we'll take a wrangle node and we'll generate like a density value and we'll say that is the color, the red channel multiplied by at mask. So this will be my emission. And then I want to set up the velocity, which will be type in set, and we want to take at flow direction, so dir underscore x, and I'll just copy this. So control C, comma, control V, comma, control V, and just change this to Z and Y. So this sets up our, velocity. And if we want to visualize this, we can try. So I can just take the color and I can set it to ramp and just pick up V. And there you go. See, so this is the velocity channel that we have. Like if we just lower it a lot, see, there you go. So this is the velocity that has been generated by the flow field. Okay, so now let's set up our particle network. So we'll take a pop network. First thing is, let's set the background to black. So we'll do dark. And I'll come to birth. I'll do impulse activation at $FF less than 120. I'll take about 300 particles. And life expectancy of 3 with a little bit of variation. And we'll set the emission to density. Yeah, see, so we have it on top. And we'll say scale point count by area and just lower the reference area so it will start generating particles. Okay, so this is fine. So let's try to press play and see what we're getting. So they are starting to move, but it's also not like it won't stick to the geometry. Like you'll see that it kind of starts to, move out, which is not what we want. So the first thing we're going to do is we'll take a wrangle and we're going to use the min pos function, okay, which will allow us to stick everything to the landscape. So I'll do at p is equal to min pos and 0, which is the input that we want, and at p. Now the point is this is not going to work right now because we didn't pick up anything in inputs. So make sure that you come to inputs and you set it to first context geometry. And that should give us what we want, which is they'll start to move, but they will stick to the ground. Yeah, see, so you're getting like some movement happening. Okay, what you can also try is, this is something that we can sort of test out. Like I hadn't done this previously, but let's do one thing. Let's take a color and we'll set it to, I just want to check this. So let's set it to flow. Okay, so let's see if we can set the density to flow rather than, instead of the measure and curvature, let's try this. So let's come into the wrangle and we'll set this to flow. And let's see what we get instead of that. So if we press play, yeah, there you go. That looks a lot better. Okay, now in order to make them move a little bit, what I can also do is I can add a force in here. So let's take a pop force and I'm going to set it to -1. So what that will do is it will just push it down. So the particles, when they start generating, they'll automatically start to move downwards. And if we want, we can also give it a little bit of noise. But what I want is, I don't want the noise to move very fast. So I'll take the pulse length to about 10 and I'll increase the swirl size and give it an amplitude of around 0.5. So what that should do is it will sort of, give the flowing rivers a little bit of waviness. Okay, now the next thing is we want to calculate the distance between these points so we can use it for coloring at a later date. Okay, so what I can do is, let's do two things. Firstly, I want to use a pop interact to just, let's see if we can make them stick together. So I'm going to take a pop interact, make it -0.1 and we'll make the core radius really small. So let's do about 0.03. Okay, and then the next thing is take something called proximity. Yeah, so you'll get something called pop proximity. So it doesn't really do anything. It just calculates the distance. Okay, and we'll say maximum distance of around 0.2. Okay, so it's not calculating too much. And let's just play this. So let's see if we are making any difference to this. Yeah, so the particles will start sort of connecting together and it should give us more, streams overall. Okay, so let it play through. What I'll also do is I'll just increase the cache over here. So I'll make it around 15,000 and let me just, play through the whole thing. And this is what we get. See, that looks pretty nice. So you get the whole thing flowing down. Okay, so the rest is fairly simple. So let's come up here. Okay, like our basic simulation is done. I'm just going to lower the point size a little bit. Yeah, perfect. And what I can do is I can just take a color node and I can set the color. So the proximity will give you something called as nearest distance. Okay, so pick up nearest distance and we'll set this down to around 0.05 or hold on. Let's try to go 0.03. and just flip this. There you go. Okay, so what you'll get is, see, so you can actually like just see the streams. So the closest, so it's setting up color based on how, particles falling within a certain radius. So what I can do is I can set this to like a blue or something, and maybe a little more intensity. Okay, that's too much. And this could be, I don't know, like a green or something. Okay. Yeah, so you can get something that looks, see, there you go. Now what we can also do along with this is we can give it a little bit of drag so it's not that fast. So I can just take a drag here and around 1.5 should be good. Okay, so let's recalculate once. Yeah, so there you go. So the drag kind of slows it down a bit so it doesn't flow out that fast, but I think it looks better. You can adjust it, okay, like according to what you want. I do want a little more of the blue. Okay, let's set this to like a dark brown or something. Okay, another thing you can do with this is we can give it like a trail. Okay, so I can use a trail over here and we'll give it about 3 and I'll set it. So I'll do an add here and make it like by attribute and ID. So it looks a little more, fancy. So you'll get like these lines going through. And then I can just take a point node and I can give it an alpha. So we'll say alpha constant value and just kind of, 0.5. And for the main particles, we'll set it to 1. Yeah, so we can merge these together. So it should look a little more fancy. Yeah, like if I press D and I'll make this, yeah. So what you'll get is you'll get like, points with trails behind them. Yeah, so completely up to you. Like that's an option that, if you want, you can have it, and if you don't want, it's fine. All right, so before we close this, let's make a few minor changes and then we'll check something. So I'm going to change this to like a dark blue as well. So the whole thing just looks like water. Okay, so it looks a lot better. Yeah. And then let's see if it's actually matching the flow fields that we have or not. Like that's important. So what I'm going to do is I'm going to take the terrain that we have and let's give it a color. So I'll just come in here. I'll come to the convert height field and just plug that in. And we're going to set the color based on the flow. Okay, so we have this. And I'll set this to like a green. And I think this is okay. Like, let me just try and adjust this a little bit. Okay, and then this one I can set it to maybe like a dark brown or something. No, I think a black is good. It's like easier to see. The other thing is you might want to give it a slight bit of peak and like push it inwards. Otherwise it will intersect with the particles and you won't be able to see them. So just take a peak and I'll set it to something like minus 0.02. So just like a slight bit. Okay, and then let's merge them together. It'll slow it down because this is a pretty heavy geometry. Like this is 1.9 million polygons, or no, so this is about 500,000 polygons. Okay, so if I just plug these together and if we start to play this, you can see the particles move along, the flow fields that the terrain had. There's a slight bit of modification because we added like a pop force, but overall it kind of moves very nicely. So if you want, like you can put like a water body down there and have the particles sort of look like they're flowing into the ocean or something. Like you can do that, but there you go. So this is the final result. Okay, so you can have your particles kind of moving down these sort of flow fields that the terrain generates. Okay, so in the next lesson, we'll do something slightly different. just another example. Like we're coming close to the end of our training. We're just two more things left. Okay, so the next lesson we'll take a look at another example. Like if you've seen the Unreal 5 demo, then there was a part in there where the torch moves and the bugs sort of run away based on where the light is. So we'll do something like that.